This conference will now be recorded.
Last week, we were discussing about Kubernetes introduction. What is Kubernetes and its architecture? Okay. So today, we'll try to set up a Kubernetes cluster. So, as we already discussed, primarily, there are two types of Kubernetes clusters. One is self-managed and managed. Managed Kubernetes like EKS, AKS, GKE, right? IKE, like each and every cloud. IBM Cloud has one service called as IBM Kubernetes Engine. This is Google Kubernetes Engine. Google Kubernetes Engine. Azure Kubernetes Service. In AWS Cloud, we have a Elastic Kubernetes Service. So similarly, there is a one more way of setting up a Kubernetes cluster using KOPS. Kubernetes Operations is a software using which we can set up production ready, highly available Kubernetes cluster in most of the clouds like AWS. KOPS will leverage AWS services like auto scaling group, AWS services like auto scaling group, command launch configurations, to create a cluster. KOPS will just create two auto scaling group, groups. There is another way of setting up a Kubernetes cluster using KOPS. Using KOPS, we can create a Kubernetes cluster, which is like a production ready and highly available Kubernetes cluster. KOPS will create auto scaling groups and launch configurations. Instead of you are creating an auto scaling group and launch configurations for your Kubernetes cluster in AWS, KOPS will create. It will create two auto scaling groups and two launch configurations. One for master machines and other for worker machines. So it will just create auto scaling groups. If we have a auto scaling group for a Kubernetes master machines and worker machines, then who will create, who will take care if worker goes down, master goes down? If there is a way to create auto scaling group for a Kubernetes masters, and Kubernetes workers. If any master goes down or any worker goes down, in that case, who will manage the machines? Who will recreate? The cloud concept. If I have an auto scaling group for a Kubernetes master, if I have an auto scaling group for a Kubernetes worker, if anything goes wrong with your master node or worker node, in that case, will I get another master, another worker? If there are auto scaling groups, right? Yes. I don't know, sir. We forgot AWS concept. You only tell me the answer. No one is responding. In AWS, we discussed auto scaling groups and launch configurations, right? Do you guys remember? Here, COPS. COPS is a software which will create an auto scaling group for a master and auto scaling group for a workers and its launch configurations. So in that case, will it be highly available Kubernetes cluster? If there are auto scaling groups which are managing your Kubernetes masters and workers? Yes. So COPS is just a software to create a Kubernetes cluster. In the background, it is going to create auto scaling groups and launch configurations. There is another way of creating a Kubernetes cluster. When I go for EKS, it's a fully managed Kubernetes cluster. It's completely managed Kubernetes cluster, which means AWS will completely own managing the Kubernetes cluster. Right? Now we have a self-managed, another category. In the self-managed, who need to manage? I mean to say, who need to set up the cluster and who need to take care about availability of masters and workers? We need to manage ourselves. So in self-managed, we can go, there are again, like we can use softwares like Minikube, Kubidium, something like this. Now, Minikube, as we already discussed, Minikube is what? Single node Kubernetes cluster. It is only for developmental purpose. Using Kubidium, what we can do? We can set up multi-node Kubernetes cluster. We can set up multi-node Kubernetes cluster. So now we will be setting up this multi-node Kubernetes cluster, right? Self-managed. Now in AWS, there is a service called EKS. So if I create this service, do I need to install required softwares? Do I need to take care about the master, the control plane components? No. This is managed Kubernetes cluster. Now when it comes to self-managed, as we already discussed, if your client is not at all ready to host infrastructure in the cloud, like AWS or Azure or Google Cloud, your client don't want to deploy their applications in the AWS cloud or Azure cloud or Google cloud. They don't want to go with the cloud, someone else's data center. They want to have their applications deployed in their own servers, on-premise servers, their own data centers. And still they want to use Kubernetes. In that case, can I go with these things? Managed Kubernetes clusters? No. In that case, I can go with self-managed. Now, we don't have any on-prem servers, on-premise data centers. But still, even though I'm using AWS, if I go with EC2, right? If I just create a servers in EC2, if I set up a Kubernetes cluster using KubeDM, can I call that as a self-managed Kubernetes cluster? If I am creating a servers and if I am setting up a Kubernetes cluster using KubeDM myself, can we call that as a self-managed? Yes, because it's a server. EC2 is nothing but a infrastructure. You are just getting a infrastructure. You are managing yourself. But when I go for a EKS, it falls under what? Platform as a service. So platform as a service, if I go for a EKS, right? So you no need to worry about setting up and managing. Now, since we don't have any data center, right? I am just creating a servers in the AWS, and I'm installing. I'm setting up a Kubernetes cluster. Even though I'm using AWS, it is self-managed. If I directly use EC2 and set up the cluster. Now, let's continue with setup. Before setting up the cluster, right? Let's try to understand minimum requirements now. Now I'm going to create a 3-node Kubernetes cluster, one master and 2 workers. One master and 2 workers. Okay. Minimum capacity for master node. Minimum capacity for master node is 2-core CPU and 4 GB RAM. Minimum requirement for master. But again, this is minimum. In real time, do we go with only this much? No. We will take more CPUs, more RAM. And workers, now I am going with the T2.micro. For practicing purpose, I am going with the T2.micro. 1-core CPU and 1 GB RAM for now. For master, T2.medium for now. And again, even though you are using self-managed in real time, do you go with only again one master? Again, even though you are using self-managed Kubernetes cluster, what is the problem if I have just one master, one control plane, only one master? So, what is the problem if you have just one master, one control plane, right? So, what do we have in the control plane? I mean to say master, what are the components we have? Who is responsible for managing the cluster, right? The master. The master is responsible for managing the cluster. So, in the master, what do we have? In the architecture we discussed last week, we have a control managers, we have a scheduler, we have a API server, we have a etcd. If you have just one replica of API server, one replica of control manager, one replica of scheduler, suppose there is some issue with your master machine, your API server is not working, your control plane is not working. In that case, do you able to deploy the applications, or if any issue happens in the cluster, if any pod goes down or any node goes down, will it try to reschedule the pods if there is a if the control plane is down, if the master is down? No. So that's why in real time you will have a multiple masters even though you are using self-managed. But if I go for a managed, who is going to take care of that high availability in the masters, that control plane? The provider, the AWS provider will make sure there will be a high availability in the control plane. So now I'm just setting up one master and two workers. But if you want to have a multi-master Kubernetes cluster, altogether it's a different process, guys. It is not like you will get a manager token and you will execute the token. It is not like a Docker swarm. If you want to have a multi-master Kubernetes cluster, again self-managed. If you really want to set up a multi-master Kubernetes cluster self-managed, you need to follow a different process. So this is the video in our YouTube channel, multi-master Kubernetes setup using Kubidium self-managed, right? You need to follow altogether a different process if you want to set up a multi-managed, multi-master, self-managed. This one. If you really want to set up, you need to follow, just go through this one, you can understand how it works. Now, instead of this one, we are setting up one more, one master, single master for practicing purpose. Now, one master and two workers I am creating. Again, I am trying to create a Ubuntu machines. I am trying to create a Ubuntu machines. Let me create Ubuntu servers. For master machine, minimum requirement is minimum requirement is 2 core CPU and 4 GB RAM. So I'm selecting T2 medium. Minimum requirement. You can't set up master in 1 core CPU and 1 GB RAM. So let me give some tag. Kubernetes master. Most importantly, the ports here. Again, we need to open few ports. Here I have given the list of ports. Here I have given the list of ports. In the master machine, in the control plane nodes, master nodes, you need to open all these ports. So 6443. What will be running on 6443 in the master? If I set up a Kubernetes cluster, what will be running or what will be listening on 6443? Here, if you see, API server. So you need to open this port in the master, and also 2379 and 2380. For which purpose? What will be running? These ports will be used by whom? The etcd server, that etcd in the master machine. 10251 for scheduler, 10252 control manager, 10250 the kubelet process. These ports has to be opened in the control plane. In the worker nodes, also you need to open 10250. What will be running on 10250? If you observe, again in the master also you need to open 10250. In the worker also 10250. What will be running on 10250? Kubelet. Kubelet. It is not API server. API server will be running on 6443. The kubelet. So what is kubelet? We discussed in the architecture. What is kubelet? Kubelet is what? Kubelet is a primary node agent. Kubelet is a primary node agent, that communication agent between your master and worker, your control plane and workers, right? It's a primary node agent. In the architecture we discussed, right? So we need to open all these ports. For now, what I am doing, I am opening all traffic. I am opening all traffic, but not everywhere. Not everywhere. I am opening for this VPC, this network only. Only for this IPs. I am opening the ports. So what is this IP range? What is this IP range? This is my VPC IP range. In that VPC only I am creating my Kubernetes cluster. In that case, whatever machines in that VPC, if this traffic is open, will they able to communicate with each other on any port within that IP range? AWS concept. Yes. So I'm opening all the traffic only for this IPs, that VPC range. Now let me create a server. Now similarly, let me create a two more machines. Let me create a two more machines for workers. For workers, T2.micro is sufficient for now for practicing purpose. I'm trying to create two machines. Trying to create two machines. Let me give it let me give it tags. I'm giving it tags, AWS tags. And here also I'll open the traffic. So I'm creating a servers first. Now, as I told, right, Kubernetes is a container orchestration engine. It's just a container orchestration software, right? Now, again, it's a self-managed. Now, do I need to install whatever softwares is required? I just have a servers now. Will the cluster will be ready if I just create the servers? Or I need to install some required softwares and set up the cluster? We need to install required softwares and set up the cluster. Now, in each and every server, what is the basic software which we need to install now in all the servers? First, the containerization runtime. Java. Why Java is required, Hare Krishna? We don't need Java here. So what is the minimum requirement? Container runtime. That container runtime can be Docker, as I told, container D, whatever. Now let me install Docker in all the machines. Then we need to install this Kubedium software. We need to install this Kubedium software and a Kubelet software. Kubedium software and Kubelet software. Using this Kubedium, right, we can set up the control plane. We can set up the cluster. So now let me set up. I already shared the installation instructions last, Friday itself. I already shared the installation instructions. Now I've created 3 Ubuntu servers for manager, 4 GB RAM and 2 core processor, for worker, T2.micro. Now in all the machines, in the master as well as workers, we need to install these softwares. We are installing Docker and we are installing this Kubedium software and Kubelet software. Right? This is common for both masters and workers. Right? Now let me log into my servers and I will install the softwares. Guys, I will do parallelly. I mean to say I will install the softwares in all the machines. But you do one by one. When you are practicing, try to install the softwares one by one. Otherwise, if you miss some commands again, it will not work. I'm going to do it parallelly, side by side, in the worker machines and the master machine. I'm going to install the softwares. When you are installing, do it one by one machine after the other. Don't do side by side. Because if you miss any one of the command, it will not work. So first, let me switch to the root user. In all the machines I am doing one after the other. Update the package manager. Now here, what we are doing? We are installing Docker containerization runtime. So let me install Docker. I'm installing Docker, and this is optional. We no need to add, that Ubuntu user to the Docker group, because I'm going to deploy the containers not directly. I am not going to deploy the containers directly in Kubernetes. So we are not going to execute Docker commands. We are not going to frequently execute Docker commands in a Kubernetes. In Kubernetes, right, we will be deploying using kubectl commands. So this is optional. You no need to add Docker user to Ubuntu group because we are not going to execute Docker commands. Right? I just install Docker, check the Docker whether it is started or not. Right? Check the Docker whether it is started or not. You enable the Docker service. If we enable the Docker service, what does it mean? You are enabling the service at a bootstrap. You are enabling Docker service at bootstrap. What does it mean? Whenever I restart my machines, whenever I stop my machines, if I start my machines, will the Docker process will be automatically started if I enable any service, not only Docker service. If you enable some service at bootstrap, will the service will be automatically started when you stop and start your machines? Right? So we are doing that. So let me Docker is installed. Here also installed, all the machines Docker is installed. Now let me do this. This is optional, guys. If you want to add it, otherwise you can leave. Guys, when you are doing, do one command after the other and one server after the other. Don't do parallelly and don't execute multiple commands together also. Now we install Docker. And what are we trying to do here? We are disabling the swap memory. As per the official Kubernetes documentation, we have to turn off the swap memory if for your Kubernetes to work properly, for your Kubernetes cluster to work properly. You need to turn off, you have to disable the swap memory. What is swap memory? Anyone has any idea? What is swap memory? Sometimes in the interview also they will ask. So whenever our RAM, our memory, right? If it is your system is running out of memory, RAM, right? The RAM memory will be swapped to the disk. It will try to maintain some data in the disk, the memory, the RAM. So that should be disabled for your Kubernetes to work properly. So your memory should not be swapped to the storage. So that has to be disabled. So that's why we are doing this one. In all the servers, disable the swap memory. So this is permanently in etcfs tab. In etcfs tab, we are disabling the swap memory permanently. Now we disable the swap memory. Now we are going to install required Kubernetes packages, that kubedium software, kubelet software and all. So first we are adding the keys, repository keys, apt repository keys. Using these two lines, we are adding the repository keys. Without adding the repository information, if I execute this kubedium, apt get install kubedium or kubelet, Will I able to install the software? Because the default repository doesn't have this package information. So we are adding that repository keys, the repository locations. So without executing these commands, if I execute this one, what message I will get? This package not found, QBDM package not found. Right, so first we are adding the repository keys. So first execute this one. We added the key, repository key. And also we are creating some file. We are creating some file in etc apt, right? We are adding this information in that file. So let me do this way. Created one file, open that file. We are adding that line and EOF, end of file. Or I can execute these three commands together like this. Now again I'm updating the package manager. Now this is where I'm installing Kubernetes related softwares like a kubelet. What is kubelet? You already know. What is kubelet, guys? Kubelet is a, don't get confused between kubelet and kubectl. Kubelet is a node agent. So we are installing kubelet and also kubedium. Kubedium is one software to set up the cluster, to initialize the cluster. I want to initialize the cluster. We are going to use this kubedium to initialize the cluster. And what is kubectl? Kubectl is what? CLI. Do I need to install that CLI in all the machines? Is it mandatory to install kubectl in all the machines? Again, in manager also it is not mandatory. In manager also it is not mandatory. What is kubectl? In the architecture I explained what is kubectl. CLI. Kubectl is not required. In fact, in the manager also not required. In real time, you will not have a kubectl in the manager. I can have a kubectl in any machine. I can take a separate machine. I can take a separate machine, just one normal machine. I can take a separate machine. Here I will install kubectl. I am going to configure kubectl. In this machine, I will configure kubectl. There is a file called kubeconfig file. We need that file. If I have a kubeconfig file in this server, if I have a kubectl installed, I can communicate with this cluster. Kubectl is just a CLI. Wherever you want to install, you can install to manage the cluster. It is not required in the master also. It is not required in the worker also. But for now, instead of taking a separate machine to manage my cluster, to deploy the application, I'm installing kubectl in the master itself. But in real time, do you get a SSH access to the master to deploy the application? In real time, do you get a SSH access to the master to deploy the applications in that cluster in real time? No. You will not get SSH access to the Kubernetes master to deploy the applications. In that case, I can install kubectl in any other server, and I will configure that kubectl. That kubeconfig file, this kubeconfig file will have information about your cluster, on which IP, on which port your your API server is running, where exactly your cluster is running. That kubeconfig file have all the information about cluster, where it is running. Now, if I execute kubectl commands in this machine, the request goes to the API server. You no need to have a kubectl in the master also. It is not mandatory, but for now, instead of taking one more machine to manage the cluster, I mean to say to interact with my cluster, I'm installing kubectl in the master. Guys, are you clear? In the interview also they'll ask, how do you deploy your application in a Kubernetes cluster? You log into Kubernetes master and deploy? You log into Kubernetes master and execute kubectl commands in real time? No. So you can have a other machine, any other machine, right? Where you install kubectl, just kubectl, and you will have a config file, that kubeconfig file. Then you execute Kubernetes commands here. This request will go to this API server. Okay. So now, since I don't want to create a one more machine, I'm installing kubectl in the master. The kubelet, kubedium, and kubectl only in the master. Now, do I need a kubectl in the other machines? As I told, what is kubectl? It's a CLI. You don't need to have a kubectl in other machines. So I'm just installing kubelet and kubedium, kubelet and kubedium in the other machines. Now, let me enable this also, kubelet service and bootstrap. Now the required software has been installed. So now I will initialize the cluster with the help of kubedium software. I will initialize the cluster, kubedium init. So this one I will execute in machine, whatever machine I want to make it as a master. So with the moment I execute this kubedium init, what will happen in the background? The moment I execute kubedium init command, the kubedium software will initialize the control plane. It will set up the API server, it will set up the scheduler, it will set up the control manager, it will set up the etcd, all those stuff. The moment I execute this one in the master machine, whatever machine I want to make it as a master, this control plane will be set up. This will be initialized. So I am going to execute this one in this machine, whatever machine I want to make it as a master. I have total 4 GB memory, right? This machine, 2-core processor and 4 GB RAM. This machine, I am going to execute kubedium init. What this kubedium init will do? it will try to initialize the control plane, that cluster. It is trying to set up the cluster. Guys, if you observe here, again, this API server, this scheduler, this control manager, this etcd also will be running as a pods. This will be running as a containers, basically a pods in the Kubernetes. The moment I execute this kubedium init, it is trying to pull the images. It is trying to pull the images and it is trying to create a pod. For API server, it is creating a pod. For control manager, it is creating a pod. For scheduler, it is creating a pod. For etcd, it is creating a pod. This kubedium init is setting up the control plane now. Now I got output. Your Kubernetes control plane has initialized successfully. To start using your cluster, you need to run the following as a regular user. So if I want to join workers, they have given this token. You can join any number of worker nodes by running the following. So this is the token. So where I need to execute this command, whatever highlighted, in the worker nodes. So this is a token. If you observe, this token has some IP address and port. What is this IP? This IP address, which machine IP address is that? The current machine, the IP address of the master. And what is this port? 6443. What is running on that 6443? API server, the API server. So now I can execute this command in these machines. But before that, what is this? They're saying to start using your cluster, you need to run the following as a regular user. What are we trying to do with these 3 lines? To start using your cluster, you run the following command as a regular user. What are we trying to do with these commands? We are trying to configure kubectl. We are trying to configure kubectl in this machine. But again, I can have a kubectl in a different machine also. So this has to be run it as a normal user. If you observe, let me take this one. Here also it is there, that is fine. Now let me come out of a root user. Let me come out of a root user. They are clearly saying run it as a regular user. So let me come out of this normal user. Guys, do I have a kubectl installed in this machine? If you see, we have a kubectl installed. But now, if I execute kubectl commands, will it work? I just have a kubectl installed. If you see, I have a kubectl installed. If I execute kubectl commands, will it work? If I just install kubectl in any machine, will I able to see? Will I able to execute kubectl commands, any kubectl command? If I just have a kubectl installed, does it mean will I able to communicate with my Kubernetes cluster? If I just install kubectl, what is required? What we need to do? We need to configure the kubectl. So what does it mean, configure, right? So we need to have one folder. In the current user home directory, we are creating one folder called .cube. Now, this file in the Kubernetes master machine, you have this file. In the Kubernetes master machine, you have this file. So what is this file? What it contains? If you observe this, what it contains? So this contains the cluster information, the Kubernetes cluster information. So if you see, if I have this kube config file in any other machine, and if I have a kubectl in that machine, will it able to communicate with Kubernetes cluster? You no need to have this in the master. If I have this file in any other machine, if I have a kubectl installed, will I able to communicate with my cluster? If you observe, what do we have in this file? It is saying server some IP address. What IP is this and what port is this? The master machine IP and API server port. And also it has a certificates information to authenticate, to communicate with your API server. So in these commands, what it is trying to say, we are configuring the kube config. So let me copy that kube config file and let me change the ownership as a normal user. Now in this machine, in the current user, there is a .cube folder, and I have a config file. That kube config file, and I have a kubectl installed in this machine. Now, will I able to communicate with API server? Now, do you see? Am I getting any error to communicate with my Kubernetes cluster? No. Again, as I told, is it mandatory to have a kubectl in the master, or can I create any other machine? Like now, let's consider I want to deploy my applications from Jenkins. From Jenkins, I want to talk to this cluster and deploy the application. Now, do I really need to SSH to this master to execute kubectl commands to deploy the application? Or if I just install kubectl in my Jenkins server, and if I have that kube config file in this machine, if I have just that kube config file in this machine, will the Jenkins will be able to talk to the API server? I mean to say, if I execute kubectl commands in the Jenkins pipeline, will it able to talk to my cluster and deploy? I can install kubectl in any other machine. It is not mandatory to install in master. In real time, you will not get a SSH access to the master to execute a kubectl commands. You will not get a SSH access to the master to execute kubectl commands. In real time, you have a separate client machines. What is client machine? The CLI. You can do this, right? Now again, I can install kubectl in my laptop also. Let me show that. I have a kubectl installed in my laptop. I have a kubectl installed in my laptop. Now, if I have that kube config file in my laptop, and if that has a connectivity, my laptop has a connectivity to with my master, will I able to execute kubectl commands directly from my laptop? Directly from my laptop, right? If I have that kube config file, this kube config file, this file, this file I have in my machine in the cube .cube folder. In that .cube folder, I'm creating a config file. And if I have this file, I will be able to talk to this machine, but now it will not work. Why it will not work? Because this Kubernetes API server, that Kubernetes has been initialized on which IP? Kubernetes is initialized on which IP? First of all, private IP. Using private IP, will I able to directly reach from outside? I mean to say different network? No. But if my laptop also part of same network using VPN, maybe if I if I have a VPN servers, if I connect to VPN servers using VPN tokens, if my laptop also join the same network, then will I able to execute these commands directly from my laptop as a developer, as a DevOps guy? So this is how the CLI works, right? Client kubectl. Now, since my laptop is not part of the same VPC where my cluster is running, it is not part of the same network where my cluster is running, I am not able to execute kubectl commands. But same thing if I do, if I create a one machine, Jenkins server, if I create a Jenkins server in the same VPC, same network, and if I have that kubectl and kubeconfig file, will I able to execute the kubectl commands from a different machine if it is in same network? Yes, right? That is how the CLI works. Suppose my Jenkins is in different VPC, my cluster is in different VPC. In that case, if I do the VPC peering, again will it able to communicate? Suppose my Jenkins is in different VPC, my Kubernetes cluster is in different VPC. In that case, if I do the VPC peering, will it work? Yes. So you need to understand all these concepts. So this is how you will use in the real time, right? So you will not directly SSH to master machine to execute a kubectl commands. For now, instead of creating a one more machine, I am using master machine only to run the kubectl commands. If you see from my laptop, I got a timeout. Why I got a timeout? Because there is no network connectivity. Will I able to ping? Will I able to reach this server? If you see from my laptop, do I have a connectivity with this server, this IP? Do we have a connectivity, or we are getting a timeout? So I mean to say data is not getting exchanged. Okay, so let's continue. In the master machine itself, I have a kubectl installed. Now I have configured my kubectl. Now how many nodes are part of my cluster as of now? only one node, only one node. And again, is that node is completely ready? If you see the status, why it is not ready? What we have to do? If you see, I will explain what is namespace. We have some namespaces. NS is nothing but a namespace. I will explain what is namespace and what is pods, right? I will explain later. Okay. Now, if you observe, I am trying to see the pods. I am trying to see the pods. What is this -n stands for? -n stands for a namespace. -n stands for a namespace. I am trying to see the pods in which namespace? I have some namespaces. I have a namespace called a default cube system, right? So I'm trying to check the pods in cube system namespace. If you see, do you see these pods are up and running? I mean to say, this API server also running as a pod, control manager also running as a pod, queue proxy, scheduler, etcd. These are running as a pod. And if you see, these are in a pending state. There will be a DNS within the cluster. There will be, Kubernetes will have a DNS within the cluster. What is DNS? What is the full form of DNS? Domain name service. Domain name service, right? So within the Kubernetes cluster, you have a DNS. You no need to use IP address for a communication within the cluster. You can use service name that will be registered in the DNS within the cluster. These are in a pending state. These are in a pending state. Why it is in a pending state? For what it is waiting? So in Kubernetes, we have a networks again. Kubernetes networks. Kubernetes networking. We call it as a CNI. Kubernetes CNI. Kubernetes container networking interface. Kubernetes container networking interface. So in Kubernetes, we are going to create a pods. Each and every pod will have a IP address. Each and every pod will have a IP address. It has to have a IP address, right? Now, do we have any networking created, container networking created in this cluster? Guys, in the Docker, the way we have, in the Docker, what are the network drivers we have? In the Docker, we have a bridge driver, we have a overlay driver, right? None, host. Similarly, in Kubernetes, we need to have some network setup. So container networking interface, it's a standard. Container networking interface, it's a standards. Defined for Kubernetes networking. Kubernetes networking. So there are a lot of implementation for this CNI. There are a lot of implementations. There are not lot of network implementations. Kubernetes CNI implementations. There are a lot of implementations. For this. You can use whatever you want to use. Like there is a CNI implementation called ViewNet, flannel, calico, something like this. There are a lot of network implementations. This is a standard. This is a standard. These are implementations. You can use whatever you want to use, right? If you see Kubernetes, networking, plugins, network implementations, right? So if you see, we have a lot of things. Let me here. You see, these are the implementations. CNI. CNI is basically a standard. So every pod has to get own IP address, right? So there should be a networking configured, which will manage the communication and IPs for your pods in the cluster. You need to deploy some network in the cluster, so which will manage the IP address for your pods and communication between your pods in the cluster. So network into, this is container networking, not the server networking. Okay. So here we have some implementations like this. So if you are using EKS, this is the plugin. I mean to say network implementation. If you are using EKS, this is the network plugin. It will be used. If you are using Azure, there will be a plugin for their own network plugin. Now you see there is a Calico network, Flannel network. Again, it's a overlay network, right? Calico, Flannel, or ViewNet, ViewNet. So these are the CNI plugins. What is CNI stands for? As I already told, container networking interface. Those are the standards. These are the implementations. So I need to deploy that network. So what is that network does? That network plugin does? It is going to manage IPs for your pods and communication between your IPs. Basically, I mean to say, it is going to manage the IP address for your pods. It is going to allocate IPs for your pods. So whatever CNI plugin you want to use, you can use. And lot of people go with Flannel or ViewNet. So if you see, my parts are not coming up, the DNS parts are not coming up because it is waiting for a network. Now by execute this command, what I am trying to do? By executing this command, what I am trying to do? I am setting up that network, CNI. Which network implementation I am using? If you observe, ViewNet. Okay. So I am applying that required. Now if you see, now you see the ViewNet related, the network related containers, the network related parts also coming up in the cluster. Now once this is ready, once this network, this ViewNet is ready, your DNS parts will be ready. Now you see your DNS parts also up and ready. Now is my node ready now? Let's verify. Is my cluster is ready? I mean to say, is my master node is ready completely? Yes. Now how can I join the workers? How can I join the workers? Now I want to join these two machines as a workers to this cluster using the token, right? Using the token, you will get only this token. So I am getting the token. Let me execute the token here as a root user again, or you need to use sudo. If you execute this as a normal user, it will not work. You have to use sudo or you execute as a root user. Now let me execute the token in both the servers. Now, how many nodes are there in my cluster? Total now? 3. 3 nodes total. This is also we call it as a node. This is also we call it as a node. I am not asking how many worker nodes. I am asking nodes. Total 3 nodes. Out of these 3 nodes, how many masters, how many workers for now? Only one master, 2 workers. My workers also ready. As I told, in each and every node, right, we will have this. If you see, you can see the IP address also. So this API server also running as a pod. API server is running as a pod. In the master, you have a API server. This is your master IP. Your control manager also running as a pod. It is running in the master. Your scheduler, your etcd. And if you see, each and every node, we have a one more component. In the architecture, I told, what is the one more component in the architecture? Qproxy. Qproxy. What is Qproxy? Qproxy is a networking proxy. Networking proxy. So this is just to manage the IPs for your. This is just to, this ViewNet is just to manage IPs, allocate IPs for your pods in the nodes. So whenever pod is scheduled to that node, it will allocate some IPs. It is going to manage IPs for your pods, this networking, this ViewNet. But this Qproxy is for what? This Qproxy is a networking proxy. Whenever I want to access that pod within the cluster or outside the cluster, within the cluster or outside the cluster, this Qproxy is going to do the connection forwarding. So we'll discuss how to access internally, externally after some time. But all are running as a pods. All are running as a pods. Now these are Kubernetes related pods. Did we deploy any our own pods? Did we deploy any our own application in this cluster as of now? No. We just set up the cluster. Now before deploying the applications, first we need to understand Kubernetes concepts, Kubernetes resources or Kubernetes objects. Kubernetes resources or objects or workloads, all are same. Guys, when it comes to Docker or Docker Swarm, we have these kind of a resources, Docker resources, container, service, stack, like volume, right? So similarly in Kubernetes, we have to understand first the concepts, then we have to deploy, right? So in Kubernetes, we have some concepts called namespaces, pods, services, replica set, replication controller. The way you have a container, service, stack, volume in the Docker Swarm. Similarly, Kubernetes has some concepts, right? So first understand these concepts, then we will apply the application. We will understand slowly one after the other. We have a replica set, replication controller, daemon set, like stateful set. There are a lot of Kubernetes concepts. Persistent volume clean. So now in Kubernetes, right? If you want to deploy any application, you need to create the Kubernetes resources. What is the frequency we do installations in real time? Whenever you want to set up any environment, like a dev environment, you need to set up the cluster. For QA environment, if you want to set up, you need to set up. For production, if you want to set up the cluster, you need to set up. Whenever you are getting a project, you want to have a cluster to deploy your application, you need to set up. If it is not already there, if the environment is not already configured. So if the project is from scratch, you are trying to manage the infrastructure. So first you need to set up the clusters, then only you can deploy the applications. So now in Kubernetes, we need to deploy any application, you need to create some objects, some resources, Kubernetes resources. Like the way in AWS, we have resources, right? In AWS, can I call EC2 as a AWS resource, EKS as a AWS resource, S3 as a AWS resource, ELB as a AWS resource? Similarly, in Kubernetes, we call these as a Kubernetes resources, Kubernetes objects or workloads, all are same. So to deploy something in the Kubernetes, we need to create these objects or resources. So first let's understand what is namespace. Kubernetes objects are basically entities in the Kubernetes system. Kubernetes objects are basically a persistent entities in the system. So this object represents something. Okay? So Kubernetes will use these entities to represent the state of your cluster. As we already discussed, to work with Kubernetes objects, whether to create a Kubernetes object, modify or delete, whom should we contact? To work with Kubernetes objects, like creating these objects or deleting, modifying these, we need to use Kubernetes API server. So how can I contact my API server to create these objects or update these objects or delete these objects? We will use kubectl, command line interface. So first let's understand what is pod. What is pod in Kubernetes? Can we create containers directly in Kubernetes the way we created in a Docker? No. So in Kubernetes, pod is the smallest building block or basic unit of scheduling in Kubernetes. So pod is the smallest one which I can deploy, which I can schedule in the Kubernetes cluster, which I can deploy in the Kubernetes cluster. Pod represents running process in a Kubernetes. Pod represents running process in a Kubernetes. What pod will have? Pod contains again what? Pod contains one or more containers. So in Kubernetes, you are going to deploy your containers with the help of pod. You are not going to directly create a containers. If you want to deploy your application, your container in a Kubernetes cluster, what needs to be created, guys? If you want to deploy your application, your image, your Docker image as a container, what needs to be created in a Kubernetes cluster? What is the smallest one which we can create? Pod. Pod represents the running process. Pod contains one or more containers. Okay. Now I will come to this namespace. Now let me take one use case, simple use case. Now I want to deploy this application, this image. I want to deploy this image. Let's take this image. Now, this image I want to deploy. If I want to deploy in a Kubernetes, what needs to be created? What is the smallest one which we can create? As I told, pod, right? Then if I want to create a pod, not only pod, any Kubernetes resource, I have to talk to the API server, Kubernetes API. With the help of what? Now, if you see, I am already communicating with my API server. Whenever I execute this command, whenever I am executing this command, what is happening in the background? Whenever I am executing this kubectl commands, what is happening in the background? Request is going to the API server and it is processing that request. So I have some namespaces in my cluster. I am getting the namespaces. And as of now, do I have any pods deployed in this namespace? By default, this kubectl is pointing to which namespace? By default, this kubectl, this is pointing to which namespace? If you see here, default, right? I have pods, but not in this namespace. I have a pods in this namespace, this kube system namespace. Now, I don't have any pods in this namespace, right? In the default namespace. Now I want to deploy some pod, some application. Okay. Now, how can I deploy? With the help of kubectl. Again, how can I deploy? There are two ways. Declarative and imperative. Imperative is nothing but using commands. Using commands directly. You can create, update, or delete Kubernetes objects. Imperative, using commands directly. What is declarative? Using Kubernetes manifest files. You can create, update, delete Kubernetes objects, manifest files. In a manifest file, you declare what you want. In a Kubernetes manifest file, you declare what you want. You can use that manifest file, something like this. Again, that Kubernetes manifest file, in what file format we are going to write? Again, that Kubernetes, suppose I want to create a pod. I can define all that information in a manifest file. Or if I want to create a deployment, or if I want to create a service, or if I want to create a daemon set, any Kubernetes object, I can define using manifest file, YML file. Again, it's a YML file. Or I can directly use commands. But in real time, which one we will use? How do you define your Kubernetes objects? Whatever you want to deploy, whether you want to create a pod, whether you want to create a deployment, again, we will use declarative YML files. Again, does Kubernetes support JSON file also? The way it is going to support YML, will it support JSON also? Yes, Kubernetes supports JSON format also. You can define your Kubernetes information, your Kubernetes objects information in a JSON file also, JSON file format. But we will not use JSON widely. 99.99% Kubernetes manifest files will be in which format? In the YML format. Okay. So you can define imperatively or declaratively, something like this. What is imperative? Using command, directly command, something like this. So something like this, directly command. Suppose I want to deploy this image, this, right? I can say Java web app, that image name, Docker hands-on / Java-web-app port, that container port. I can execute command something like this directly. Now using this image, it will create a pod. Now since I am not mentioning namespace also, in which names, you see what I got output when I execute this command? What is the output I get? What is created? What is created? Pod. Now that pod will have how many containers? That pod will have how many containers? Only one for now. Again, do you see a pod now? You see a pod now in my cluster? Yes. So that pod, like the way you have a Docker inspect, in the Docker to see more details. If I want to see more details about my Kubernetes object, any Kubernetes objects like a pod, service, anything, what command I can use? kubectl describe. I want to describe my pod. Now this pod has how many containers now? If you see here, one. Okay. Now each and every pod has an IP address. What is the IP address of the pod? If you see, this is the IP address of the pod. Now who is assigning these IPs for the pods? As we discussed already, that networking implementation, that CNI. Now within the cluster, I can access using this IP address also, pod IP within the cluster. But will I able to access from outside using this pod IP? Guys, in the Docker, each and every container has a IP. Each and every container has a IP in the Docker. But in the Kubernetes, you will not have a container, will not have IPs. Pod will have IPs, right? So I can access within the cluster using this IP. whatever that content we have in that. You see, I am getting some response, that Tomcat homepage. But will I able to access this directly from outside? I mean to say outside the cluster from a different server, maybe outside the cluster, like from your system or any other server not part of your cluster. No. In that case, how can I access from outside? So there is a concept called service. Again, there is a concept called service in a Kubernetes. There is a concept called service in a Kubernetes, right? So we need to create a service for that pod. In Kubernetes, service is different. In Kubernetes, pod is different, service is different. Pod represents the container. Service is basically to access those pods. In Kubernetes, in the interview also they will ask, guys. In the interview also they will ask, what is the difference between Docker service and Kubernetes service? Kubernetes service. Okay. So in Docker, service represents what? In Docker, service represents what? Docker service, in Docker, service represents one or more what? Containers of same image. In Docker, service represents one or more containers of a same image. And again, we can use that service name for a communication within the cluster, right? Does one service will be able to communicate with other service using the service name in the Docker? If you remember, we deployed Spring Boot application as a service, Mongo database also as a service, right? Are we able to access within the cluster one application, other application using that service name in the Docker, right? But when it comes to Kubernetes, service, when it comes to Kubernetes, service represents what? It's for a communication. It's only for a communication. In Kubernetes, service is for a communication. Service makes our pods accessible within the cluster or outside the cluster. Within the cluster or outside the cluster. But you may have a question, sir, within the cluster, why can't you use pod IPs? Suppose now you see within this cluster, this is my master machine. I am able to access this application using pod IP from master machine or in the worker machine also. From the worker machine also I am able to access that. You see, from the worker machines also I am able to access that pods using IP. But why can't we use IPs, pod IPs for internal communication within the cluster? One application want to talk to other application. Why can't I use? Because one problem, not because pod will have a more than one container, right? Not because of pod will have more than one container. The problem here is pod IPs will keep on changing. Pod IPs will keep on changing. And also, what if my, one application, for one application, I have multiple pods, multiple replicas. Do we need some kind of a load balancing within the cluster again? Because if I have multiple pods, in real time, you will not have only one pod for that application, right? You will create a multiple pods. In that case, do I need some kind of a load balancing and routing between those pods within the cluster? So that is where service comes into picture in Kubernetes. Now there are different types of services we will discuss in detail in the next sessions. But for now, I want to access this outside. I want to access this outside. There are different services we will discuss later in detail. We have a cluster IP service. We have a node port service, right? Now, this node port is like a post, in the Docker, you are doing a port mapping, port forwarding, right? In the Kubernetes, this node port is like you are trying to map some host port, that node port, to access that from outside. And again, what is the node port range? In the interview also they'll ask this question. What is the node port range in Kubernetes? You can't use whatever you want to use. There is a range, 30,000 to 32,767, I think. Yeah, 30,000 to 32,767. This is the node port range to access outside. Okay, so I can directly do something like this imperatively. So this is not a deployment now because it got changed. Something like this. Now I am exposing that pod. Basically, I'm trying to create a service. As of now, I don't have a service for that pod. For this pod, I don't have a service. This is for a different purpose. This represents, SVC represents service. This is for a different purpose. Now, by using this command kubectl expose pod, my pod name hyphen port. Basically, this is service port. This is service port. Okay, I'll explain later, guys, all these things in detail. Now, what type of service? Node port. Now, I got a service. I got a service within the cluster. Within the cluster, I no need to depend on the IP. I no need to depend on the pod IP. I can use this service name within the cluster. One application want to communicate with other application, I can use this one. But outside, what is this? You see some IP here, so some port here. This is the node port. Using this port, you can access from outside, node IP and node port. Any server, node. Node is nothing but any node, your master node or worker node. Any node out of this cluster, either master node or worker node, right? Whatever node. You open that port, whatever port you got for that service. What port I got? Basically, that 331,000. I'm opening for everywhere. Now I can access using this IP, node IP and that node port. That port, whatever port, 30, 1020. If you see, did I open the port correctly? Okay, let me see. Guys, I'm just deploying some sample application. In detail, we are going to discuss about all these things again. Okay, so let me do this. I need to modify this one because it is not taking. Okay, let me give. We will not use commands, guys, in real time. We will use YMLs. I'll explain that. Yeah, target port is 8080. Yes, fine. Because the target port is nothing but your container port. Port is again changed because I deleted. That node port is changed because I have deleted and recreated a service, right? So the node port is changed. Now I am able to access the application. Yes, guys, we'll continue tomorrow. Just I want to show this sample application, whatever I applied. Now I created a service and I am able to access that application from outside. You see, my application is running as a pod container. This is just a sample application we deployed using commands, but in real time, we will not deploy something like this, right? So before you are directly creating a pod, creating a service, you need to understand all these concepts. What is namespace, right? Why do we need namespace? Then what is pod? What is service? In detail, we will continue tomorrow, guys. Tomorrow, first we'll try to understand what is namespace. Why do we need namespace? Then we will understand what is pod, what is service, right? Slowly we will understand all these concepts in the next session. Kubernetes is very, very important, guys. Don't miss any class, okay? And try to practice whatever we discuss. Today, we just set up the cluster, right? So tomorrow we'll continue with namespace, pod, service. Yes, each component have its own certificate, right? There is a certificate, CKS files got generated for communication. kubectl will use some certificates to communicate with API server. Yes, it will have its own certificates. So today we just set up the cluster, guys, and we deployed sample application, but actual concepts will start tomorrow. Any questions, whatever we discussed today? Okay, if you are clear, we will continue tomorrow with actual concept. What is namespace? Why do we need namespace? Then what is pod in detail? What is service in detail? We'll continue tomorrow. Okay. Thank you, guys. I'm stopping the session for today. We'll see you tomorrow.